simplified sheet. Okay, guys, we're going to do, and I should have put a goal in there, but I guess I was kind of pressed for time. Okay, guys? Justin, we'll see some people come up to the board and try the problems. A function f, capital F, is called an antiderivative of little f if the derivative of that antiderivative is equal to little f. Okay? How do you know a function's an antiderivative?
If you take the derivative.
Take the derivative. Okay, so that's what this section's about. I'm not exactly sure why it's in this chapter, but it is. And there might be a little bit of it on your test on this. I'm also going to try to put together a worksheet, a packet of problems to help you review for your Chapter 4 test. Now, it's Tuesday and Wednesday. Tuesday is the individual, Wednesday is the partner. I'll tell you the optimization problem was with a partner on Wednesday. There's one optimization problem. There's a lot of related rates, because we had related rates. Those are the big ones, max and mins. But I'll go and see what I can find for you guys. Okay, now this is a definition. If f is truly the antiderivative, if I take its derivative, I get the original function back. And then this is a theorem. If f is an antiderivative of little f on an interval I, then the most general antiderivative of little f on the interval is capital F of x plus some arbitrary constant, c. There is on bottom page 318, those are all your integrals. They're also probably on this sheet. And try to get the answers online too. This is the blue sheet. You should be able to do these. You should know these cold. And when you guys have done antiderivatives, so you remember that when you do an antiderivative, it has to be in the form of one of these. And you're going to have to do some work. Not in this section. And they're also going to get the physics. So I made you a little lesson on physics for tomorrow to get it all in there. So find a function given that derivative. So who wants to come up and try this one? Or you want to try it on your paper first? No, no use substitution, straight old derivatives.
I like it right now. The answer.
There's a whole bunch of stuff there.
Negative 4 cosine x plus.
Yeah, that part I had to write it out.
Over 5.
So go ahead and try that. Somebody wants to put up on the board, you guys can just try it. We have to get this worksheet done first.
This whole thing, it's a whole side of a paper.
I divided it first. I actually showed that stuff because I wanted to get it right.
Divided first.
Later, you're only in a room.
Go ahead and answer.
Doing it in my head.
Is he right?
I just hit my head.
Do you remember the rule?
2x to the fifth of
Oh, well, hold on. Stop. No, stop. I didn't mean to do that.
and then you get 2x to the fourth minus x to the thing.
I don't know. I just said
Yeah, 2x to the 6th.
Well, Justin skipped a few steps because he didn't divide this out for you. This is equal to 2x to the fourth minus, then that's x to the 1/2 over x. That becomes x to the negative 1/2. X to the 1/2 divided by what? No? So g prime of x, let's clean it up, is equal to 4 sine x plus 2x to the 4th minus, and when I do these, you're going to subtract those. You have to have the power rule. So it's minus x to the negative 1/2. Mitch can't see around. No? Not quite. Well, we're going to find out. By the way, what is the antiderivative of x to the n? X to the n plus 1 over n plus 1. Yes, it is. So g prime of x, that's the reason why I don't skip steps, because if I tried to do it in my head, I went back and picked up my paper where I did it because I wanted to do it right. And this is, what's the antiderivative of sine? Negative cosine of x plus 2x to the fifth over 5. That's much easier to see now.
2 squared x?
Minus 2x to the 1/2 plus c. And this would be wrong as well.
You didn't do the thing yet, so why do you have to put the C in?
I didn't do the thing. Oh, I meant g, not here, not g prime. There's a little typo on the sheet that I haven't fixed. Yeah. Because the antiderivative of x to the negative 1/2 dx is x to the positive 1/2 divided by 1/2. But dividing by 1/2 is the same as multiplying by 2. Multiply this by 2, that by 2. You can either do this and do this every time, or you can just remember that you have to multiply by the reciprocal.
Oh, sorry, I'm seeing 3 over. That's fine.
Okay. Now, example 3 is kind of like a differential equation. Kevin, are you going to come up and do 3?
Yeah.
Okay, we ready for me to change the slides?
That works.
Wow.
And there's a little typo, and it's on example 4.
Here, let's box some.
It's like,
And the answers are on Blackboard.
Which one's number 4? So,
We have to change pages, and there it is, example 3.
alright, so we got.
Now we're going to try to find the function given an initial condition.
Oops. Jeez. Can I write it all?
No, you can't distribute that.
Oh, okay.
See, what we're trying to do is, we know a lot of this, but we want to be better at it.
I don't want to do that.
You want a 5 on your AB subscore.
I want to go to jazz.
There, that looks better. And then what are we going to do with that? That's F prime, so what's F? Well, either the X didn't change any. Do you guys remember what that one
Wait,
is?
you can do 20 over plus.
20 over 4. 20 over plus, yeah. 20 over plus.
No, that's not right.
Can you do that?
Mm-mm.
Kevin, you should have left it like it was.
No, it looks nice. Jessica remembers what the 1 over 1 plus x squared is. It's up on my wall someplace. Inverse tangent
Oh, it's, yeah.
of x. What have your 20? There you go. Plus c, but he's not done. That's what f is. You better write equals f of x. And now we want to find out what c is. I have an initial condition.
Oh, you plug in 0.
And negative 2.
Okay.
Why would you always say you're finding C?
Let's see. Yeah.
You don't want C though.
Yes, we do.
You can just leave it as C.
No, we can't now if we have an initial condition.
So, negative 2.
Negative 2 equals,
And then you
no. You're skipping steps. You skip steps, you get in trouble. You have negative 2 equals 1. That's 0, right?
Yeah.
Plus c. What's c equal to?
Minus.
Yeah. So what's your answer?
Uh,
Yeah, this shouldn't take too long to do this. Yeah, now you recognize the inverse tangent? That's why you have to memorize all these antiderivatives on here. And that's all you need to know. And the ones with little stars, you don't have to know. When we're done. Oh, it won't be very long. Unless Kevin does that.
it's beautiful. Am I recording right now?
Yes. Okay. Are we ready to go to 4?
Last video, it would tell you that Kevin wrote that.
No, because Vader said right.
No, I may have a typo here, you guys. This should have been f prime of 0. Sorry. Yeah. And guess what? You get to do this twice. And tomorrow we'll do the physics. You can compare with your neighbor. Justin, you going to do this one? Example 4. I have a typo in there.
No, typo.
Yeah, I forgot. This is an f prime of 0.
4x plus 30 plus.
You're going to have a plus c and then find c and then do it again and find the next constant.
Oh yeah, Miss G.
Yep.
Miss G, I can do this one.
Let's see, 4x.
Why don't you just write it down? Or write it up here. Yeah, these aren't too bad. But we didn't do problems like this last year. Not in this way.
4 plus C equals
4. Right? 4x cubed. C equals 4, right? Yeah.
I want to use my calculator.
Not 4.
No, how's it? Isn't it just -2? Because it's 3, 1 minus 3. So it's 4 plus 3 minus 4.
Dude, X is 4.
No, it's 1. Oh, which one's the
Wait, that means, if that means 1, 0, that means X is 0.
Yeah.
What is 4? So why can't I draw my C backwards? So C equals 4.
Yes.
So the first one. Correct.
Is C -3? Yes.
What? You got -3?
Yeah. For the second one. So x 4 plus x cubed minus 2x squared plus 4x minus 3.
Well, how'd you get -3?
Yeah.
How'd you get -3?
Looks like one.
So what did you get for your equation again? Say that again.
X to the 4th plus x cubed minus 2x squared plus 4x minus 3.
Yeah, buddy.
Alright. Oh, I see what it is.
This one is like a.
Yeah, I forgot to plug in my line though.
Which, that's a cube.
Let's see it.
Try the last one. It's the same process, but a little bit different functions.
That one was
That was the first. You gotta do the second.
I'll do it twice. I did it twice.
I like and
Second C.
Why would you do it up there so I'm a little chilly?
I didn't have a pencil to complete it.
What happened to the one with the next rock?
Yeah, I tried to half it, then I just like.
How about that one? Oh, what happened to this? I always write the answer down. I don't know what happened to the work.
I want to hear maybe.
Okay, here's another one. At least it didn't have a typo there. Okay, Matt, are you going to come up and do this one?
Yeah, I can do it.
Come up.
Miss G, Vader just took my pencil.
It's gonna be Ellen.
I'm gonna dump all the blueberries. Yeah.
Look, it's driving me.
4 over x is Isn't it?
All right?
It's gonna want minus 3 and 4.
So 0 equals negative log of 2. That's fine, right? What does this say? Why is this minus?
It should be plus.
It should be plus.
How bad?
No, I wrote it down wrong. It's my fault. Plus x, which is 2. So what's c equal to?
ln 2 minus 2, ln 2 minus 2.
Okay, so the function, so we have it complete. F of x is equal to negative log of x plus log of 2 minus 2. I just threw that one in because it had the log in it. Well, that's what the assignment's like on this one.
No, I know they're all negative.
Oh.
So we don't have to solve for C sometimes when you're doing the 3 times.
It depends. If you're given initial conditions, you have to find C.
No, but like, oh, and I have
That is done.
Do we have to do this? You have to find C when you have like the limits to the integral too, right? It's not limits, but you know.
Fundamental theorem of calculus. That's not in this chapter. Not yet. Next one.
So do we even have to do this somewhere? Because like we don't know that.
How do you know unless you've practiced?
But like.
It's not very long. We have 2 days on this anyway.
Oh, really?
Or 1 day. One day we're gonna have 1 day of review.
That's,
wait, is this our last chapter, last section?
Last section in this chapter. We still have chapter 5, which has a lot of BC topics in it.
But no, but for chapter 4, is there a last section?
This is the last one. Right? We didn't do Newton's
what
method.
is it to us?
Tuesday, Wednesday. Wednesday's the partner with your calculator.
I thought it was Wednesday, Thursday.
I moved it because we don't need 2 days of review. No, we got to do polars, and I want to make sure we have enough time to get polars in before spring break. You don't want to be rushed on that. That's new and it's hard. Okay, so we still have some other major topics to do.